How are you doing?
Good, good.
I should get the pronunciation of your name correct. Qingqing?
Yep,
Oh,
yep,
Qingqing. Oh, okay.
yep.
That's easy.
Yeah, Qingqing Cao.
Cao.
Yeah.
Okay. Let me introduce Qingqing Cao, a software engineer at Nuro. Nuro is a robotics company that develops autonomous driving technology and was founded in 2016 by two former Waymo engineers. At Nuro, Qingqing works on the data platform powering its autonomous platform. She holds a bachelor's in transportation engineering, a PhD in civil engineering, and a master's in computer science from the University of Pennsylvania. Before joining Nuro, she interned at Twitter as a machine learning engineer. Her background spans radar signal processing, machine learning model evaluation, and large scale back-end systems. Qingqing, thanks so much for joining me.
Thank you. Thank you for having me here.
So I'd love to jump in and learn a bit more about Nuro. Tell me about Nuro. What's their core mission?
Sure. Nuro is a self-driving technology company. So their mission is to make autonomy accessible to all. As you just introduced, we founded it in 2016, and we just celebrated our 9-year anniversary.
Oh, wow. So what are some specific technology and solutions that Nuro provides?
Mm, So Nuro license its core technology called Nuro Driver. It can support a wide range of applications from robotaxis and commercial fleets to the personal owned vehicles. With technology proven over years of self-driving deployments, Nuro gives automakers and mobility platform a clear path to autonomy at the commercial scale.
Oh, I see. Okay. And so what does that mean, accessible to all? Anybody can
Anybody,
purchase this
anyone.
technology?
Yes, from this Nuro Driver can be deployed to the robotaxi, the commercial fleets, and also to the personal owned vehicles. So this
Oh,
technology will be accessible to all.
okay. So tell me about some of your customers then. Are these mostly commercial customers like car manufacturers, or do you actually have individual customers? And what does that look
And
like?
we don't support individual customers for now.
Okay.
It's our customers are organizations that want to bring autonomy to their vehicles and services, like the automakers, the mobility platforms, and the operators of commercial fleets. So we
Oh, I
partner
see.
with them to integrate and deploy the Nuro Driver in their program.
Okay. So can you give me some names of customers, like big customer names that we would know?
Yeah, sure. Because we recently announced a partnership with Lucid and Uber. So we
Okay.
will, yeah, we'll help to build a next generation of global robotaxi program. And this is created exclusively for the Uber ride-hailing program. Together, we will build and deploy 20,000 or more robotaxis in dozens of markets, including the US and international markets. And we're very excited about this collaboration and long-term partnerships.
Okay. So you mentioned Uber. You also mentioned Lucid.
Yes.
What is Lucid?
So Lucid is the automaker. So Lucid will focus on provide the vehicle, and Uber will provide the mobility platform. And for Nuro, we will provide the technology.
I see. So what does that mean? That means in the future, if I want to get an Uber, I open up my Uber app, I request an Uber. What's going to pick me up?
Lucid will pick you up, but
Okay.
it will, yes, it will stamped with the Uber and Nuro together on its vehicle.
Oh, I see. Okay. So this is basically competition with Waymo. Is that correct?
Not really. I would not say the same kind of the Waymo because they don't have collaboration with the mobility platform. They
Oh,
deploy themselves,
yeah.
so it's still different.
But it's the same in the sense that if I need a ride, I can call a Waymo. A
Yeah,
Waymo will show
that's
up. There's
true.
no driver.
That's true.
And in this new partnership, I'm still going to request through Uber.
You're gonna request for Uber.
Okay. And then
Lucid will come. They
Lucid
just use
made
the Lucid
vehicle.
as their vehicle.
Oh, I see. And that'll show up and everything else will be the same, except there's not going to be anybody in the car with me.
Yes.
Okay. So less conversation, I guess. But I enjoy my conversations with Uber drivers. So Nuro does not sell autonomous cars. You
No.
you only sell the technology.
Yes.
Okay.
We provide the driver the software, the compute, the sensor, the mapping, safety, architecture, and infrastructure.
Well, how does your work on the data platform support the Nuro Driver system specifically?
So I work mostly on the data backbone
Okay.
that powers the Nuro Driver. In the whole picture, that means when the data coming in, you have the data ingest and storage. We collect and organize massive volumes of data from our vehicles, simulations, and operations. Then the data goes through the processing pipelines. We turn the raw sensor logs into some high quality data sets that autonomy, machine learning, and analytics teams can use right away. For the data access and governance, we make the data discoverable. So different team can search for the specific data set they want. And the data need to be secure with clear quality, privacy, and compliance standards. And also we provide some self-service tooling and APIs so engineers can just move fast with less manual work. We think that I'm specifically working in the data discovery. So we want to make the data easy to find and trustable. We maintain you can imagine that as we maintain a living catalog with data, the metadata, the lineage, and usage, so that people can quickly find the right data sets.
Right.
And we need to provide the UIs, the APIs to filter by things like some scenario type. Like you want to see the scenario that the vehicle is pulled over at the stop sign or the traffic lights. We provide the tools for you to search for
Oh,
that.
okay.
For some like you can also filter by some location, time, or the weather, whether it's a raining scenario or not, whether it's at night or daytime. And also we need to surface some data. We also monitor the data quality. We surface the data quality issues. We need to flag some anomalies, and we also need to support annotations for the machine learning training. So this is end-to-end integration. We tie the data discovery into a broader platform so the data can flow smoothly from ingestion to final use.
Okay. I can imagine it's just massive amounts of data. I think you used the word massive.
Yes.
What kinds of data are we looking for here? You mentioned cars, you mentioned simulations. Like, what do we see for a given car driving
Mhm.
on the road using this technology? What's the data that you see every minute?
So you can imagine actually a single autonomous vehicle can generate terabytes per day.
Yeah.
So
One vehicle.
yes, one
Okay.
vehicle. And this includes the sensor data, sensor including the camera, because it's a video data, so
Right.
will be large. The LiDAR, the radar, we have some point cloud data. And all the sensors, they generate data at a very high frequency, at 10 to 100 hertz. And those kind of data must be processed and stored. We also have some location data. And also there are some log that maybe that operators making some annotation on board. We also need
Oh,
to store that kind of data. And also for the simulation part, simulations usually done offline when we training the model or
yeah.
when we want to replay some scenario and simulate whether it can be improved with our latest model or technology. We simulate the data. It's also need the same set of sensor data, and also there are a couple of stages. After we get the sensor data, we need to do some planning that it needs to generate the trajectory of the vehicle, how well
Mm.
the vehicle will go in the next few seconds.
Oh, I see.
Also, you need to predict what's the how's the environment to look like. Will there be pedestrian or
Hmm.
cyclist coming by? That kind. We also need to store the environment, those temporal data, kind of data.
I
So
see.
yes, a very massive different types of data. Um, it's sensor fusion. I would say sensor fusion is combining the video, point clouds, the GPS, all of those together into a coherent understanding of the environment.
Does a vehicle with this software have a 360-degree view
Yes, it
around
has.
it? And also how far?
It's actually 360 degree. We use the lidar. It's not the camera.
Oh,
So the lidar will spinning, always spinning, and get a sense of what's around the vehicle.
oh, I see. How many vehicles do you think or do you know are running this software in the US? Is this US only?
In the future, we'll also deploy to other countries.
Okay, so currently
That's
it's
in the
US
plan.
currently US only. How
Yes,
many vehicles? Do you have any sense of how many vehicles are on the road that are using this technology?
hundreds of.
Hundreds.
Yes,
Okay. And so each one is generating terabytes of data per day.
yes, that's a really massive data.
So you make this accessible to different teams within Nuro.
Hmm.
That's your job. You make this accessible. You also provide tools to access the data. What does that mean? You mentioned APIs. What
Hmm.
other ways could I access this data? If I worked for Nuro on a different team, how can I access this data? What are the different ways?
It depends on what kind of data you want. Are you
Okay.
doing a machine learning training? Like if you want some specific data, like let's say if you want to train your vehicle to behave better in some specific scenario, your previous model doesn't work well when it's at night. So you want to find the data that's specifically for vehicle driving at night.
I see.
Yes.
Okay. That's interesting. These are self-service kind of tools, right? API.
Yes.
Oh,
We also have some internal UIs just for our machine learning researchers to access the data
oh, I see.
like easier and faster.
What are the unique infrastructure challenges that come along with supporting this type of system?
Yeah, I would say there are a couple, so there are many challenges.
Yeah.
Uh, just as I talk about the data scale and the complexity of the data, the massive data, like different um, kinds of data. It's not like a web application. You have the
Right.
structured data. Yeah. So and also it's actually bringing up the question, how do we how manage those data efficiently, like
Hmm.
for this kind of scale data, because you might have terabytes of data. And you know that we usually store the data in cloud because no one wants to store that massive the data on-prem.
Yeah.
You need to balance like the data tiering. For the data stored in the hot tier, it's usually cheaper to access the data, but it will be costly to store the data. But if you move the data to the cold tier or the archive tier, it's making the data very cheap to store for a long time,
Right.
but very costly to access them. You need to
Less.
balance that.
I see. So
Yes.
in other words, like, if a given car is generating all this data on a daily basis, the question is, do you need data from 6 months ago or 12 months
Mhm.
ago for that car?
Yes.
Like, is that needed anymore? It's done. You already made the predictions you needed to for where that car is going. Is that data needed anymore? And the idea is that you move that to cold storage or
Mhm.
archival buckets.
Yes. Yes. Time is definitely one factor affecting this. Sometimes the the most recent data is usually the one that access the most. But they're also different by the topics. There are different data topics. Like some sensor topics will be more
Oh,
they will be access more than the other types of the data,
okay.
because these are used for training or for use for evaluation kind of thing. And there are some other kind of data, say we make some annotation on board, and this is
Mhm.
just for tracking purpose, not used for machine learning purpose, then we probably won't need to access it for a long time.
Right.
But time is not the I would say you can't just decide this by time, because most of the time we will see when we do a large evaluation, we will have to access like even 2 years ago's data. That's pretty normal. So
Right.
you can't just store it in the architail, and then bring them up all together one time. There will be a very high cost.
Yeah. Can you talk about any of the details of the data infrastructure, like cloud platforms that you're using, anything at all?
So the infrastructure we mostly using the GCP, the Google Cloud
Okay.
platform. We store the data there.
Mhm.
We also have some on-prem data center.
Oh, okay.
So we build our internal file system
Oh,
that user doesn't need to care about where the data actually stored. They just need to know, oh, there's the data and they have the same namespace with the data. I just call some file API. I can find the data. I don't need to care where the data
oh,
located.
I'm curious. Do you store any data about who's in the vehicle?
Actually, we do.
You do.
Um, but for now, it's just the driver information because we need the operator's information. We need
I
to
see.
um, just for tracking purpose.
Yeah.
And also, it's also in the effort for improving our data qualities. We want our data to be collected in with the high quality.
Okay. What's been one of the most rewarding engineering problems you've helped solve at Neuro?
So actually, I have two comes in mind. So just the one I touched a little bit, the storage, and I will talk another one in the data pipeline later. So the storage is the picture. We already talked about the picture. Every vehicle is a rolling data center. It's
Mhm.
constantly recording what it sees and does, and it adds up to an ocean of logs, videos, sensor data, decisions, and we need a way to store and find it reliably, quickly, cost effectively. So we could store our we want to build our global file system. So it will be just a single namespace where the data just lives. No, and also no matter what backend hold it, we store it in GCP today, but next time we move to other cloud provider, we also want to access that data.
Mhm.
And also think you also need to handle some problem like replications, the failover, so the data always stay available during even the outage.
Right.
And we need to enforce some policies, like some people working on training model, they shouldn't be accessible to the testing data set. We need a very strong guard for that.
Mhm.
And we also need to, for the cost management, it needs to handle how to automatically move files from between the code and the hardtail to control the cost. At our scale, we have, because we just said we have hundreds of petabytes of tens of billions of the objects. We have one, we have, now we have the one source of truth, where the file, how many copies of it. So
Mm.
this internal file system is simplified the operations and improve the reliability, save the real money.
Mhm.
Another one I want to talk about is in a higher level, is in the data platform that I recently working with. The data platform, we want the data pipeline to continuously improving the model. We for specific one that I'm working with, we use the active learning approach. So the model will flags what's the most informative new examples. We get those examples labeled and fold them back into the training and then repeat this process. So the model can learn and improve itself. So my focus is on being the infrastructure that makes this loop fast and safe at scale. It has to be high throughput ingestion, and we have reproducible jobs. We need to have some lineage tracking evaluation. The challenges we need to avoid the bottlenecks that across the network, the storage and compute. It needs to handle many data sources and formats. And also we need to make it easy to rerun without duplicating or corrupting the data. So when it works, the result is simple. We find the right data faster. We label it with the high quality and ship more models, ship better models sooner. So this whole feedback loop is very rewarding.
So these two things, data storage, data pipelining. The data storage system that you described, universal way to access the data, granular access for different users and teams, moving data around to control cost, creating efficient copies of the data. Did you create this system? Did your team create the system?
Yeah, our team built this system.
What is your team?
So the team is the storage team.
Storage team. Okay.
Yes, I actually,
That's a good name.
previously worked in the storage team and now transferred to the data platform team. So these are the two
Oh, I see.
I mainly worked with.
And for the pipelining, same question. Your team built this pipelining system, taking data, improving the
Yes,
model using active learning in real time. You created this kind of efficient loop.
yes. It's just a part of the whole picture.
Right. This active learning that you described, is this happening in real time constantly?
Not in real time. We don't do it in real time.
Okay.
For the model improvement, mostly we can do it offline. We don't need to spend the pressures
Yeah.
onboard compute resources for model training.
How often do you do that? So at some point you say, okay, we're going to retrain the model. We're going to use active learning, take the necessary data to do that and send it to the model using a loop. Is that weekly?
Yes, it can be done weekly.
Okay.
And actually, the data ingestion is happen every day. For the every day when this data come in, we use the model to find the data that the model is properly like we find the data that we feel it can improve the model the most.
Yeah.
And we use this data to train the model.
What kind of code are you running to do this?
We use VS Code. And for now, for the language, we use Python the most.
Oh, okay.
Because Python is easy for
Yeah.
machine learning workflow and data plumbing. But for the backend, well, the performance and the real time matters, we use C++. For some service, for some backend services and storage system, we use the Golang.
What does your data platform team look like? How many people on that team?
So we have the whole team, I would say more than 20. The entire team that work in the data platform, the data pipeline from ingestion to the evaluation.
Okay.
Because this is a large team that we handles a couple of things here. We have the ingestion and discovery. Just as I talked, we have the data importing in, ingesting. We did some indexing, and we need to make the data discoverable for the downstream users. And we have other sub-team, the evaluation. They need to build and maintaining the infrastructure for the large-scale evaluation, the validation, and metrics computation for the autonomy and simulation. We need the ground truth, the team that doing the labeling. Because for the machine learning, you need some human label, right?
Yeah.
They build the workflow that will have the human in the loop, that support the human labeler to efficiently label the data we have, and also they monitor the data quality for this for the training for the downstream teams. And we also have two other sub team on the compute. That's the team that maintain and build the scalable compute infrastructure for the data processing and simulation, those kind of workflows. And visualization team, which is working on the visualization tools and platform for the autonomy development.
I see. When you say data labeling, what are they labeling the data with? For the machine learning, what are they actually labeling the data? Are they looking at data and trying to identify potential accidents?
So it actually depends on how you gonna use your data. Is you gonna use your data for perception training? Is basically it labels the data with the correct objects
Oh,
around the data, right?
oh, I see.
Well, yes, but if you want to train the data for behavior, like how your vehicle should drive at some scenario, then you should the good behavior. So
Oh,
when
I see.
we collect the data, when we have the operators, we really hope they drive the vehicle with the high quality, with the good behavior. They shouldn't be a dangerous driver, of
Right.
course. Then when those data collected, we have labelers, they have some guidelines. If the data is too close to uh, the front vehicle is not good, it's not that good, right? If the vehicle is too slow in the highway, that's definitely not good. So there are some guidelines for them to label whether it's a good behavior or not.
I see. So they're looking at the data and they're identifying problems in the data. For example, objects. Maybe the vehicle is not recognizing a tree that's too close to the vehicle that's driving or another
Mhm.
car. And then for behaviors, it's identifying bad driving.
Mhm.
So that's what they're actually identifying in the data that's being
Yes.
ingested. I see. That's interesting. What's your favorite debugging or development tool these days?
So currently, I use Cursor a lot. You probably already
Oh,
heard
you
about
do?
Cursor.
Oh.
Yeah, I do. I do because we are AI-powered company. We try to catch up all the AI advanced in our company. So we introduced Cursor to our company. It's a AI assistant code editor.
Mhm.
Um, it's very, it's like a patient pair programmer.
Yeah.
You just never get tired. You can. I used to. I usually use it to generate some test cases for me, and used to generate some scaffold services,
Mhm.
scaffold code, and sometimes I use it to help me understand some unfamiliar code path. And I would say, and it would not replace thinking, but it just shorten the path.
It's a tool.
It shortened path from I have a hunch to I have a working testing change in a very short time. So it's a big win for the workflow and the iteration speed, especially for the startup company.
Why did you choose Cursor? How did your organization select that specific tool?
We did have a specific team for that. They compile different AI assistant code editor,
Mhm.
and I'm not aware of the specific the reason for
Mhm.
choosing Cursor finally, but it turns out it works well.
Your dissertation topic was on the application of ground penetrating radar on asphalt pavement. What is that?
So okay, that's finally goes to the civil engineering part. So I will try to explain it this way. Just imagine you standing beside the road under the construction. You have the roller passing, the asphalt is hot and fresh. So how do you know if it's compacted and just right without breaking the surface? This is problem not only concerned by the constructor, but also by the people like living around the place, right? No one wants their front driveways always blocked by the compactor or the roller. So we use the ground penetrating radar, the GPR, to step in. It's send the electromagnetic wave to the pavement, and those wave pulses will reflect back based on what it sees underneath. It could be the air voids, the moisture, or a layer thickness changes. In traditional civil engineering, we usually have human to drill the cores, or we have the human to analyze those reflection data and manually estimate the thickness or
Ooh.
spotting some anomalies. So I want to use machine learning to make it smarter. So I started building the pipelines that took the raw GPR signals. These are really messy, noisy signals collected during the real-time compaction, and I need to clean them up using some advanced signal processing techniques. And it's just like you can think of it like tuning an old radio. So you can actually hear the music, not just static or noise. What's really excited me is uh, using the machine learning as the bridge between the real world data and actionable engineering decision.
Hmm.
Engineers care about care about like, is this road going to last? Do we need to repave? Have we compacted enough? Not about the radar waveform. So we train the model to recognize the patterns in the radar echoes. So I could translate this raw messy signals into the engineering metrics like compaction, quality, or the pavement thickness,
Mm.
instead of spending hours in the lab or just cutting cores out of the road. They can get the result. The operators can really get the results instantly in the field. They shift. So the machine learning techniques I use that shift from the data, the raw data, to the decision, from
I
the
see.
signal to the solution. Is it compacted enough? Okay, if it's done, then we can stop there. We don't want to overcompact it, but also we don't want to compact it. So that's my PhD dissertation is mainly focused on um, how to use this machine learning to help to solve the real engineer problems.
How is this being used and where is this being used?
So I had my PhD in University of Illinois at Urbana-Champaign.
Mhm.
It's we already have some cooperation with some local compactor, and we have the radar installed in their compactor,
Mhm.
and collect the data and do some test trial there.
Mm.
Also, this is also apply for a patent and it's approved this year. We hope to apply this to more commercial, to collaborate with more commercial compaction companies. So this technology can be used more widely.
How wide of an area does the detection work? Like, how big is the area?
It's right under, you can think of it as a footage just under the compaction roller.
Yeah. Oh, okay.
Yes, because when you compact, when you drive, when the compactor um drive and it's compact the pavement, it needs the real time feedback. Am I compacted enough? Can I move to the next spot? So it just need to
I
be
see.
under that footage.
How, if at all, does this work help you in your current role at Nuro?
I would say, um, it it's really a point that I find the machine learning can empower
Mm.
the traditional technology. And within that in mind, I really grow and conviction that autonomous driving was the future of transportation.
Oh,
It's not only limited to with the radar, because I study the radar, the signal processing, the data, the machine learning. I want
yeah.
to transfer that piece of knowledge to the autonomy world.
How did you figure that out? How did you know that that was going to be the right transition for you to make that leap to autonomous driving?
So I would not say it's good for everyone in civil engineering. Definitely, it's not correct to say that.
Mhm.
Just for me, because my initial work is most heavily focused on data and signal processing,
Mhm.
and so you use the radar, but we are not looking on the surrounding area of the vehicle. We are actually looking inside the pavement.
Right.
It's just a different direction, but we use
Right.
very similar
Different direction.
technology.
Yeah.
Yes, different directions. Yes. So it just to provide me a natural entry point into the world of machine learning when I pursue my PhD. So within that in mind, I feel um, everyone want a world that we don't need to spend many time on the road. We
Mhm.
can save some time back
Right.
while driving on the road. We can spend some time with our family. We can
Mm.
spend some time with with ourselves. That's how I feel. That's the future of transportation. That's the future of the autonomous driving.
I hate driving. I'm sick of driving. So I love this.
Yeah, yeah, I know. I can relate. I really want to spend some time with my little one instead of just driving there. Sometimes when my little one screaming in the back seat, I'll be crazy.
Yeah, no, I know what that's like. When you're driving, how do you feel about it? Do you think differently now that you're working in this field? Are you picking up different things while you're driving? Are you thinking about it constantly?
And not constantly, I would say, but definitely a different mindset.
Mhm.
Before stepping into the driving industry, I would say just driving just take me from one location to another location. But when I stepping in, I started to think, okay, in some scenario, am I able to drive safely?
Hmm.
Then what about a robot? Like a self-driving car, will it able to handle this kind of complex
Yeah.
scenario? Or will it even be safer to drive in a self-driving car because it's not like human can get tired,
Hmm.
human can get like
Distracted.
distracted. Yes.
Yeah.
So I try to think more about it. And like human, basically they're using their eyes, they're using vision to determine where to drive, how to drive. But the self-driving vehicle, they can use the other sensors. You can use
Yeah.
the radar and lidar, where that make it even safer.
Right. And there's no blind spot, right?
No blind spot.
Hmm.
That's true.
That's interesting. No blind spot. That's a step in the right direction.
Yeah. 360-degree of view.
Yeah. What would you tell students or early career researchers who are considering a similar transition that you made, civil engineering to autonomous driving?
So I always say, I will offer some pieces of advice. You need to translate your skills.
Yeah.
Your research and academic experience have given you the available skills like critical thinking, problem solving,
Mhm.
and deep understanding of your domain. This is the same. This can be easily transferred to the industry. Um, you don't you don't just list your publication. You need to really explain how your work impact the world.
Mhm.
And also, you need to embrace the mindset shift. You need to understand the goals the company is different from the academia. You need to prepare to work collaboratively. You need to learn like what other teams are working on, how you're gonna collaborate with each other.
Mhm.
You need to prioritize some business-oriented approach. So it's less about perfection, but more about iteration and impact. So this is a very huge difference between academia and the industry.
Mm.
And you also need to clear like what motivates your transition. For me, I would say it's my desire to see my work directly impact the society by making autonomous driving a reality. Like having those kind of strong motivation can help you navigate the challenges of the transition and don't afraid to be pivot. Like your past experience isn't waste, it's just to make you unique, I would say. And also don't forget to invest in the fundamentals. You still need to learn some basic fundamentals like the math, programming, system thinking, those core those core skills that will make it much easier to adapt to the new fields.
Mhm.
And you would always get comfortable with learning on the job. Especially this is a very fast moving industry, so no one has all the answers. You need to find yourself. You need to be curious, persistent, and willing to collaborate.
So here's a question. You mentioned programming, right? A core skill, programming. I
Mhm.
know you took programming in the MCIT program. How do you feel about programming? You use Cursor, right? It helps you. you can get to where you're going faster. Where do you think realistically, where is programming going? Is that a skill, do you think, that people will continue to need to learn?
Definitely, I would say, because probably I'm kind of the old-fashioned people. I think to really under something, you cannot just pick something up piecemeal. You need to understand what's coding look like, what's the programming look like. You need to understand the algorithm,
Yeah,
data structure, and system in a systematic way. You need to speak the same language as your colleagues. If you
right.
don't do um, programming yourself, you just rely entirely on the vibe coding, then you don't know how to solve the bug. You cannot purely be confident in what they provide you. You
Yeah.
need
Right.
your own test cases.
Yeah.
So it's still very important to learn all the fundamentals, all the techniques that are related, and before you have vibe coding that assists you. I would still say the vibe coding is still to assist you, not to replace you.
I mean, bottom line, you need to understand what cursor AI gives you. It's going to give
Mhm.
you code. You need to be able to understand that code.
Yes, definitely. Even when I'm using the vibe coding, either at work or at my own self, some project, I
Mhm.
would say from my experience, I cannot fully depend on them. Sometimes,
Right.
y- at least you have to critical think. Is it correct? What kind of prompt I need provide
Right.
to make it better. And you need to identify the gaps between what it provides to what you really want to make. And for identifying those gaps, you still need to know the knowledge
Mhm.
of, and you need to understand what they write for you.
What are you excited to learn next, either in your current role or more broadly?
So I would say I'm most excited about to use the potential of to use the generative AI and its application in those autonomous vehicle space. I'm willing to learn more about how we can leverage those fast-paced technology like LLM, the generative AI, to create the most robust simulation for testing, validation, and how as well as how they can help our system learn from the raw unlabeled data.
Hmm.
I believe that by training more general purpose model, we can unlock the potential for truly scalable autonomy. And I'm excited to at the forefront at this exploration.
Have you done any experimentation with that? I'm imagining, like, if I just simplify it, if I took 1 day of data for a vehicle, 1 day, if I could take
Mhm.
all that data and feed it to an LLM and ask the LLM to summarize what's happening with this vehicle and ask it specific questions. How well is it driving? What's the path? Where is it going next? Like, is there any kind of experimentation around that that's happening?
Oh, I don't do this experiment myself,
Yeah.
but I would say it cannot start from very raw data.
Okay.
Yeah. Probably in the future,
Yeah.
as the technology just iterate, we probably able to have this end-to-end model that take the raw data, take the what the vehicle sees on board
Yeah.
to the planning, to the trajectory it's recommended. But still, I'm afraid we still have some way to go.
That would be amazing, right? If you think about it, if it could just handle all of that data, the raw data,
Yes,
you have to
definitely,
deal with the scaling issue. Obviously, it's so much data, but and
definitely.
let the LLM explain what's happening with that vehicle and also make predictions.
Mhm. We know that it can already handle some video
Yeah,
format data. It
yeah,
can explain what happened in the video, if they're a pedestrian, if they're
right.
a cyclist. Um, but I feel it's still a way to, definitely some way to go for it to learn where the vehicle should go or how it should go.
Yeah.
Yes. Probably it's already some people already spend some time on it.
Yeah, I'm sure.
We will see. Yes.
Are you ready for the lightning round?
Sure, we can start that.
30 seconds each.
Okay.
I should have
Let's
mentioned.
do it.
Favorite programming language right now?
Okay, I would still say Python. It's just versatile.
Thank you.
Yes.
One,
You like Python most?
actually, I like Java more than Python. I teach Python and Java. I like Java more than Python.
Okay,
But
got it.
that's just me. One piece of tech you couldn't work without.
Okay, I would say it's a little bit weird. I would say my Linux terminal is just simple. It's just the way I debug and automate the run code experiment. It just feels like home base for me.
I thought you were going to say cursor.
Okay. I will not have cursor in the following answers. I promise.
Backend system or tool you admire most?
Okay, I would say Kubernetes. It's not perfect, but it gives me the idea of abstracting the infrastructure into something portable and scalable. So I would say it's incredibly powerful, and this also changes how we think about like deploying the software.
What is it? Can you describe Kubernetes in 2 sentences?
No, that's a little bit hard for me. Okay, but I try to expand it. It's a portable. You can imagine it as subtract the infrastructure you need to run to deploy some software into a portable kernel.
I see.
So you can run. It's runnable there. You don't need to specify what environment you need.
Yeah.
Yourself. But it's just have everything for you.
Is it a portable infrastructure?
Yes.
Best advice you got as an engineer?
So I would say, don't just fix the bug. You need to fix the system that allowed the bug. This is the advice I get from my mentors, and push me to think beyond the code into the process, the testing, the long-term reliability.
What's the first thing you built that made you feel like an engineer?
During my PhD, I built a pipeline that could take the messy reader data and actually predict the payment thickness in real time. It's it's just a startup project for me, but it's really that moment make me saw the prediction lined up with the real measurements. And this is the first time I thought, okay, this works outside of the paper.
What's your favorite band right now?
Okay.
You know there's a band called Pavement, right? You might want to check them out.
Okay, I definitely need to check them out.
Pavement.
Okay, that's interesting. That's quite interesting.
Yeah.
I'm kind of an old-fashioned people, so I would say Westlife is a very old band. They recently had a reunion.
What's it called?
Westlife. Have you?
No. Oh, I see. Okay.
Yeah, I listened to it 10 years ago and still sometimes now.
And now you can go check out Pavement.
Okay, I would do that.
Yeah. What's an activity you do outside of work?
I like hiking. So I would say it's the very opposite of the debugging. Just no screen, no Wi-Fi, just the trail. It just helped me reset it and come back with the fresh energy.
Is that hard for you? Like, it's hard for me to step away from screens, like, period. Is it hard for you to get into that headspace and just put everything away, go outside and hike?
I try to push me to do that.
Yeah. Is there a little transition time there? It takes you like 15 minutes to kind of transition.
It's okay, I would say, because for now, like for my daily life, even I don't do hiking every day. I still go for a walk. Just try to put everything aside and go for a walk. I know it's a period that helped me to refresh on my mind.
Great. Thank you very much.
Thank you for having me here.
Yeah, this was fun. I learned a lot.
Thank you. I also learned a lot from you.
Thank you very much for your time.
Thank you.
Okay.
Bye.
Thanks for watching. If you like this, be sure to subscribe. More interviews and demos coming soon.